Hello, good afternoon, children. Today we will be doing question number 2 from exercise 13.1. Now, see what the question says. A vessel is in the form of a hollow sphere mounted by a hollow cylinder. We are having a vessel, we are given a vessel. A vessel is in the form of a hemisphere. This is a hemisphere. This is a vessel, it is in the form of a hemisphere mounted by a hollow cylinder, and above this we have a hollow cylinder, right? Then we are given the diameter of the hemisphere is 14. This is the hemisphere, this diameter is 14 centimeters, and the total height of the vessel, this height is 13 centimeters. Find the inner surface area of the vessel. We have to find the complete surface of this vessel, right? Now this vessel is made up of two parts. One is hemisphere and other is cylinder. When we have to find the inner surface area of the vessel, that means we have to find the inner surface area of hemisphere plus inner surface area of cylinder. These two we have to find, right? Now what is the formula for inner surface area of hemisphere? सरफेस एरिया ऑफ हेमिस्फेयर. व्हाट इज द सरफेस एरिया? जब हम हेमिस्फेयर का सरफेस एरिया निकालेंगे दैट मीन्स नाउ वी नीड कर्व्ड सरफेस एरिया ऑफ हेमिस्फेयर, क्योंकि अंदर का निकालना है खाली. एंड द फॉर्मूला फॉर दैट इज 2πr square. Now we are given diameter of the hemisphere as diameter of hemisphere is 14 centimeters. That means radius will be 7 centimeters. Now we need the radius. We have got the radius 7 centimeters. We'll put this 7 centimeters in place of r and we find the curved surface area. So that means curved surface area will be 2 into 22 by 7 into 7 into 7. Then we solve it and we get the answer as 308 centimeters square. This is first area that we have got. Now we will find the surface area of cylinder. What is the formula for inner surface area of cylinder? मतलब curved surface area of cylinder. Inner surface area of cylinder. What is the formula? The formula is 2πrh. 2πrh. Now in this case we need r and we need h. Now when we look at the figure of the question, whatever is the radius or diameter of the hemisphere, the same is for the cylinder. When the radius for hemisphere is 7, the radius for cylinder will also be 7. So radius to aa gaya 7. Now we need the height of the cylinder. We are not having the height of the cylinder, but we are given the total height. Now see carefully. When we are given this hemisphere, the radius is 7 here. This side also it will be 7. And this total height we are given as 13. Till here the height is 7. So what will be the upper height? Height becomes 6, right? That means in place of this total 13 we can write 7 height for this and 6 height for cylinder. So we put the same values for this. 2 into 22 by 7, in place of r we put 7 and in place of height we put 6. This and this cancels. We get the answer as 264 centimeters square. Then we have to add both to find the inner surface area of the vessel. Inner surface area of vessel is equals to 308 plus 264. This comes out to us as 572 centimeter square. Fine. I hope this question is clear. Okay. Now we move on to the next question. Okay. Now next question we have question number 3 that you people can try on your own. Now we move on to question number 4. Now question number 4 is, a cubical block of side 7 centimeters is surmounted by a hemisphere. We have, this is question number 4, we have any cubical box, right? And it is surmounted by a hemisphere. On the top of this box, it is surmounted by a hemisphere. Like this. Right? Now, what is the greatest diameter of the hemisphere? इस ये जो हेमिस्फेयर इसके ऊपर है, see for example, suppose this is the cube that we have, this is the cubical box that we have. Now above this we put a hemisphere. Say for example, this is a hemisphere, this lid is a hemisphere, and we place it above the cubical box. Now what can be the greatest diameter for this hemisphere? The greatest diameter for this hemisphere can be the what? Edge, whatever is the edge of this cube, that will be the greatest diameter for this hemisphere. देखो cubical block अगर ये 7 centimeters है, suppose this side is 7, that means this side is 7, this side also is 7, and if I keep a hemisphere over this will be the diameter. If you draw complete line, that will be the diameter. So that means what can be the diameter for this hemisphere? That will be the edge of the cube. The edge of the cube is 7. That means the greatest diameter that a hemisphere can have will be 7. Right? So first question is over. What is the greatest diameter of the hemisphere? So greatest diameter for the hemisphere can be 7. Greatest diameter will be equal to edge of the cube. Edge of the cube, that is 7 centimeters. Right? Now we have to find the surface area of the solid. We have to find the surface area of this complete solid. What will be the surface area of the solid? See, surface area of this solid will be, complete solid will be surface area of the cube plus surface area of the hemisphere minus सर्कुलर रीजन जो ऊपर बन रहा है इसको माइनस करना पड़ेगा. कैसे? सी, we need the surface area of this cube. We have taken out. इसमें सब कुछ आ गया. Top, bottom, everything is included in the surface area. I have kept this hemisphere over the cube. We have taken out the surface area of this cube also, of this what is this? Hemisphere also. अंदर बाहर सारा आपने surface area ले लिया. Then I have kept this over the cube. When we have kept it over the cube, if you see carefully, then this region, this circular region is coming twice. Once we have calculated the circular region with the cube, also we have calculated the surface region. This is the surface region. We have calculated it for the hemisphere also. That means when we have to find the surface area of this solid, what we will be doing? Surface area of the cube plus surface area of the hemisphere minus area of the circle or circular region, which is coming twice. For with the cube also we have included it, with the hemisphere also we have included it. लेकिन हमें वो एक ही बार चाहिए, so once we have to subtract it, right? How we will be finding? We have to find total surface area of the solid. Total area of solid. How can we find the total area of the solid? By surface area of cube plus surface area of hemisphere minus area of the circular region. Area of circular region. Right? Now we have to find the surface area of cube, we have to find the surface area of hemisphere, also we have to find the area for the circular region. Okay? Okay. So now what is the formula for finding the surface area of cube? Surface area of cube. What is the formula? Total surface area of cube will be 6 into side square. That means 6 into what is the side of the cube? It is given to us as 7 square. And when we solve it, we get the answer as 294 centimeter square. Then we will be finding surface area of hemisphere. What's the formula for surface area of hemisphere? It is 2, just now also we have done. It will be 2 pi r square. Right? So solving it, 2 into 22 by 7. R in this case will be 7 upon 2 because the diameter was 7. So radius can be 7 by 2 into 7 by 2. On solving it, we get 77 centimeters square. Then we have to find area of the circular region. Area of circular region. And the formula is, for the circle, what is the area? Pi r square. This is 22 by 7 into 7 by 2 into 7 by 2. It comes out to us as 77 by 2 centimeters square. Right? All the three things we have got. Now what we'll be doing? Total area of solid will be 294 plus 77 minus 77 upon 2. This will be 294 plus 77 by 2. Then this will be 294 plus this will be 38.5, and on adding it we get 0.5, 2, 3 and 3 centimeters square. Fine. So this is your answer. Okay. Right, now question number 5. After this we have a hemispherical depression is cut out from one face of a cubical wooden blocks such that the diameter L of the hemisphere is equal to edge of the cube. Determine the surface area of the remaining solid. Same thing we have to do for question number 5 as well. Exactly the same formula, but in place of 7 it is replaced by L. The side of the cube is given to us as L. Okay. So in this video we wind up with this question, and in the next we will be starting with question number 6. Okay children, bye bye, God bless you.